to 1 as 1 upon 4 Okay, now I'm the co-host. I can share my screen finally. Now you can see my screen, right?
Yes, sir.
This was the question, right? And this table we have x equals to x 0, 1, 2, 3. And the probability that x equals to x is this one upon 8, 1 upon 4, 1 upon 8, 1 upon 2, right? And you have been given the random variable y equals to 2x plus 3. Correct? So you have to mostly you have to calculate the if you have to calculate the covariance. You need what? You need the expectation of xy minus expectation of x and expectation of y, right? This you would have calculated simply, right? So you are facing the issue in calculating EY. Have you calculated? Hello, Aditya. Have you calculated EY?
Isn't it directly substituting the values of x in the equation
you can
of
directly
y?
correct.
Yeah, okay.
And you can get 2x plus 3. So whatever you are getting, just multiply with 2 and then sum with 3, right?
Right.
Okay.
When it comes to xy, do you multiply the values of x and y?
Here.
Uh-huh.
Yeah, this is xy only. So you can do x into, what is that? 2x plus
2x
3.
plus 3.
So this is what? 2x square
plus 3x.
Plus 3x. So you have to do that 2 into ex square plus 3ex.
Ex.
This you can calculate. You just have to square this thing.
Square the values, yeah.
Okay, and multiply with the respective probability.
Yes.
And then you can calculate this, multiply with 3 and do the subtraction, you'll get the value.
Yeah.
So I guess this is fine, right? Or should I calculate the final answer?
No, I mean, for me, it's fine. It's just only one question I want to ask is instead of doing this ex square and this, can I form the table where the x and the probability of x are written directly there? Can I actually add another column or row and then say y is equal to so much and then y into x multiplied?
Okay. So you are
That
asking to you are asking to construct the table for y. Huh?
Yeah.
Okay.
And
so
like
for y, we can't calculate the probability value, right?
Yeah.
So we can't calculate. That's why we can't make the table of the what you can say not marginal, the what you can say this one fxy, the multiple variable sort of things that we can't make. That's why. Yeah.
Okay.
So just have to go through this method.
Okay. Thank you.
Oh, yeah. Thank you. So Aditya, is it clear now? Okay. So yeah. So lecture 2.
Yeah. Can we discuss that?
Lecture 2, right? Okay.
Yeah.
Lecture 2.
Week number 3, towards the end. Yeah, lecture 2, week number 3. Yes.
Lecture 2, right?
Yeah.
Should I open the?
So towards the end, if you can recollect towards the end. Yes, towards the end.
Okay. Where? At the end.
Towards the end. Where? Yeah. When we are Yeah, this one, sir. Yes.
Okay, this question you're asking.
Yes, sir.
Okay, so this question is, suppose 10 balls are thrown uniformly at random into 3 bins. Okay, what is the expected number of empty bins? Okay. So see, if you'll go through the probability approach, it is going to pain you, right? So the sir, I guess, has went through the indicator method where he has just defined, I guess, okay, he has just defined xi equals to 1 means the first empty, like if x1, like for example, if x1 equals to 1 means the first bin is empty or the first bag is empty, right? If okay, and so if I'm throwing the 10 balls, so x1 equals to 1 means, yeah, so x1 equals to 1 means the first bin is empty,
right?
Bin 1 is empty, so all the 10 balls went to the second, third order. Okay.
Yes, second and third one.
And x2 equals to 1 means bin 2 is empty and rest of the ball would have, all the balls would have went to the 1 and 3, and x3 so similarly. So okay, so what we have to calculate, we have to calculate the summation, expected number of what was that? Expected number of balls, expected number of empty bins. Okay.
Yes.
So expected, we have defined the random variable in such a way such that if we are able to calculate expectation of x1 plus x2 plus x3, that is going to give me the expected number of empty bins, right? Right? Okay. So how will you do that? So we have to just do the expectation of x1 into plus expectation of x2 plus expectation of x3, right? How will you calculate this one? So expectation of x1 equals to 1, that means what? So the first bin was empty. What is the probability that the first bin would be empty? 1 by 3, right? Are you getting my point?
Okay, so we are treating it uniformly, right?
You're checking what you told. Can you repeat that?
We are taking it that uniform. They are having equal probability that each one of them can.
Yeah, it's an equal probability that if we are having 3 bags, if I'm throwing the ball, okay, in uniform, this is a totally uniform experiment we are doing, right? So you can assume this is a triangular sort of prism, not a dice. You can assume with 3 sides only, and the dice is like not biased. It's a fair dice.
Okay, so 1 by 3. Okay.
Right. So 1 by 3 will be the
3.
Yes. So okay, yeah. So the probability that this x1 would be empty is 1 by 3. So this is for the first ball, right?
This is for the first bin. This is for first bin.
Okay. Sorry. This is for the first bin. And the rest, how did you calculate expectation of x1? Generally, we calculate the expected.
We take the value what random variable is taking, and then we multiply with the associated probability.
Probability, right?
Yes.
Okay. And then 1/3 is that the probability the first ball is empty. Then the rest of is to 2/3 is for the next one. Okay. Wait. Did I do any mistake or what? Like 1/3 is fine. How did he solve that? I'll just go through that. Okay. So he just he went through the same approach, like if first bin is empty, he has just represented this in an indicator, like he has just defined an indicator or a random variable where whenever x1 equals to 1, that bin is empty. Okay. And then the probability that x1 is empty. Okay. So that would have went to the, okay. Got it. So see, x1 equals to 1 means that what? The ball, there is no ball came to the first bin, right? So the probability is what? Like the probability that the both.
Sir,
Yeah.
Sir, here what the professor said is that in each bin, the probability of going is 1/3. So the bin is empty is 2/3.
Yeah. So yeah, that also you can say if 1/3 is the probability that
There are 10
empty.
balls and there are 3 bins. So in each bin, if the ball is going, the probability is 1/3 for a ball to go in a bin.
1/3 is to go in a bin. So the probability that it is an empty bin, okay, that is 2/3, right?
Yes.
And that is for the one ball.
That is for the one ball, and then there are 10 balls. So
yeah,
if
so that's why the probability is 2/3/10, right? This is what sir has told, right?
Yes.
Okay.
And so this is for xy equals to 1.
Yeah, this is xi equals to x1 equals to 1, right?
Yes. xi equals to 1 for I equals to 1 to
3. So this can be applied for probability that x2 equals to 1 also.
Yes.
And the probability would be same. Similarly, for the probability that x3 equals to 1 is also 2/3/10, right? So this is just a probability. And if you have to calculate the expectation, then you have to just multiply it with the number, right?
Yeah. So since these are all same, so just multiplying with it 3.
Oh, okay. 1/2/3 to the power 10 plus like 1 into 2/3 10. So this simply 3 into 2/3. This is the expected number of balls that is empty. Expected number of bins that is empty. Okay. So I guess this is clear, or should I explain it again?
This 2/3 to the power 10 is the probability of that one particular bin is empty, right?
Yeah, yeah.
So there are
because the probability, yeah.
So there are 3 bins, so we are adding it, right?
Yeah.
So we are getting 3 into 2 to the power 2/3 to the power 10.
Yeah.
Okay, can we come back to video, sir? What is the final answer? This sir is saying.
This is the probability. Three has, yeah, okay. So this is the final answer, I guess. 3 into 2 to the power 2/3 to the power 10. Right?
Okay.
Okay. So anything else from third week, or
Sir, I have a question on AQ 3.6. Question number
3.6.
Question number 6. Question number 3.
Question number 3. Yeah.
This one, last one.
Okay. So here you have to calculate the covariance. You have to calculate. Okay. What is the issue in this? Yeah. So correlation you have to calculate. First you have to calculate the covariance and then standard deviation. Everything.
The issue is I tried it multiple times, but I am not able to get the answer. Those are available as an option over here.
Okay. So how? Okay, I'll just try to. Okay. So the expectation of x, y. You have to calculate, right? I'll just make the plot. So this is x and this is y. We just tell me the value 0, 1, 2. Here it is 0, 1. So 0, 0 is how much? The probability value?
1.5.
Okay. So like for example, whatever the value here it is. So EXY you have to calculate XY, FXY, XY. Okay. So this will get cancelled. You don't have to do anything. This also got cancelled. So you are left with only this much. Okay. This is 4. Right? Are you getting my point? Okay. Who is asking this?
0, 0 is cancelled.
Because every time we'll do that. Here
Okay.
it is XY, right? So
Okay, got it.
some part will come from 0. So that will make it cancel. Now you're left with 3, 4, this 4. So this you are having this value also. Fxy is given for all the values. xy is also given, so you can calculate exy. There is no problem in that, right?
Okay.
Okay. So now you have to calculate ex. How do you calculate x into fx?
FX.
Okay.
Yeah.
So fx, how did you calculate? You can calculate that you are just
Uh,
fix the value x equals to 0. Calculate fx marginal distribution for x equals to 0. Then calculate the marginal distribution of x equals to 1. Just do the summation of these three. Do the summation of these three. Do the summation of these three. You'll get value, right? Okay. So x you already know. Like you can just skip this one because x equals to 0 will cancel that. You can just calculate the marginal distribution for x equals to 1 and x equals to 2, right? And then do the summation. You'll get the expectation of x. Similarly, do for the expectation of y. How do you do that? You can just skip this one. You can calculate for this and for this because this will cancel because y equals to 0. And then you can calculate just do the summation. Will give you the marginal distribution for y equals to 1. Do the summation for this row, or yeah, this is row, and you'll get the marginal distribution for y equals to 2. Do the summation for this 2. Just multiply the y into 1 and do the summation for both the thing. You'll get the expectation for y, and then you just subtract it. You'll get the value for covariance. Okay, and then you have to calculate the standard deviation of y because the correlation is what? Correlation is covariance upon a standard deviation of x. Okay, so you have to calculate the standard deviation of x. How will you calculate that? You have to calculate the variance and then take the square root. How will you calculate the variance? You have to calculate the expectation of x square minus expectation of whole square. Okay. So how will you calculate the ex square? So ex square you have all ex square. How will you calculate? Ex square is just x square into fx. So this is a marginal distribution you already have calculated. Okay, and just do in spite of x equals to 1 and 2, just write it here. X1 into this marginal distribution of x equals to 1 plus 2 chi square. 2 chi square into fx where x equals to 2, right? This will give you. Okay. So similarly, you can do for y also. Ey like here, and then you will just subtract the mean value. Mean means the expected value, whatever you have calculated earlier. You'll get the variance, take the square root of that. Then calculate for the y also. Do the same process for y, you'll get the value. I guess this is clear. Maybe you are doing some there is no conceptual like a problem. Must be doing some calculation error because anybody can do the calculation error in this type of question because there's so many calculations. Okay.
Okay. Thank you, sir.
Okay. So should I move to the fourth week? It's a problem discussion of week. Actually, I joined it. No, it's not a problem discussion for week 3, but some of you were having issues, so I just discussed the week 3 concept. I'll just go through the week 4 now. So how many of you have seen that? Can you raise your hand? Week 4, I guess many of you have not have seen, right? Okay, so Vinayak has seen.
Sir?
Yeah.
Sir, I have a small doubt in graded assignment of week 3. No, I do not want a detailed discussion of that. There was a problem of the geometric progression, like the defective items were there, like some.
Which question?
So below, not that.
I'll just tell you a brief.
Yes, sir, about that. There are 8 something.
8th question.
No, sorry, 7th. Sir, above this.
Above this one.
Yes, sir, yes. So, sir, in that question, there was a line like the defective item are kept aside. The first defective item is also kept aside. It affect the like question, or we should just progress with the direct geometric progression.
Okay, so I didn't see that. I'll just read out and then I'll be able to know. So suppose suppose 8 in 100 products that are coming from a production line is defective. Okay. And then suppose we randomly pick and keep aside product from the production line till the first defective item is obtained. Okay. Let the random variable x represent. So it's a GP, I guess, direct.
Yes, yes. It's a geometric progression. Everything is okay, but I have just one confusion that that first defective item is also kept aside. It going to affect that question, or it's like in any case we just found that defective item and keeping aside in.
Your voice is like I'm getting some noise. Maybe
Am I audible?
you can write it.
Hello.
Yeah. Now it's clear. Can you speak out?
Yes, sir. Actually, I am like the geometric progression thing is clear to me. I have just a small confusion that the first defective item is also kept aside. This line is going to affect this question, or it's just a normal geometric progression?
Okay. So this line you're asking, assume the first defective item is also kept aside.
Yes, sir. Yes.
So if it is written, so there is some, I guess, you can't skip this question like line. Like whoever has made this question has made it clear that you can't like skip this statement. That's why they have written this.
Okay, because except this line, the other part is very clear, like that it's a geometric progression. We can directly do that.
So it's like from the reading itself, I didn't solve that, but I think it's a GP only.
Yes, sir.
So you can just approach the same, like the GP, you can just go through that maybe. Because I can't like, so
Okay,
this
sir.
Sir,
graded-
actually,
I have a
if you
question.
don't assume that, you cannot apply the GP.
What?
So if you don't assume that, you cannot apply the GP.
Yeah. That's why maybe
That's why it is given.
it's written.
Okay. Then it's like, okay, sir.
I have a question here. Are the digits not necessary? Because my question actually says suppose 6 in 100. Now what you're showing is saying 8 in 100. Is that?
It is different for everybody.
Yeah, it's different for everybody.
Different for everybody.
Values are also different from 8, but yeah, the question is same.
So the value is different for like it's a parameterized form. Like we have just used some Python skills to just change the value so that everybody will get. Earlier, everybody was copying.
Okay.
So
Yes,
please
sir.
don't like copy because everybody would be having different values. So you can ask if you're copying also just use some smart. Ask them the concept. How did you solve? Okay. So maybe after tomorrow we can discuss this, but
Okay, sir.
Okay. So anything else like except graded? Anybody else has any issue?
No, sir.
Okay. So anything else from third week, or should I move to, because we are having 1.5 like 1:15 minutes. So should I move to the fourth? Like
Yes, sir.
okay. So what is the deadline for fourth week? The submission for fourth week?
Next Wednesday, sir. Next Wednesday.
Okay, Wednesday only. Now you have time. Okay, so just open the PDF. Okay. The fourth is pretty simple. I'll just tell you the concept. If you have not seen the lectures also, most of the things you already have read in the what you can say in the stats one. CDF PDF you already have read, right? Stats one, I guess. How to
Continuous distribution are not so much in depth in the stats one. It was not so much in depth. It was told that it will be covered in stats two.
okay. So CDF you already know. Like, can somebody define that CDF? What is that cumulative distribution function or distribution function?
With respect to discrete or with respect to
Anything
continuous?
like for the formula. See the
Correct.
whatever
So
it is.
as per my understanding, what goes I will talk more with respect to discrete random variable.
Both for this same for both,
No,
like
for
discrete.
continuous, I have some doubts, sir. So I will come to that. So
Oh,
cumulative means, it includes all the previous PMF also. Say, for example, if my random variable is taking 4 values, 0, 1, 2, 3, and 4, so it's total 5 values, right? So my random variable will take probability at 0 and probability at 1 and probability at 2, 3, and 4, so on, right? Of course, the summation will be 1. So if I calculate CDF at 3, x equal to 3, right? So it means CDF at 3 will include probability at 0 plus probability at 1 plus probability at 2 plus probability at 3. So that will be my CDF. So at every point there will be a jump. Like while moving from 0 to 1, so it will jump with respect to the probability at 1. So once we move from 1 to 2, again there will be a jump as per the probability at 2. And at 3, again there will be a jump, and the jump will be equivalent to the probability at that particular point. So this is called cumulative. But the problem what I am encountering, sir, during continuous random variable, like in case of discrete, professor explained about PMF. First of all, it is PMF, and then he moved to CDF, right? But in case of continuous, what is happening? First of all, he is explaining about CDF and then coming to PDF. So this concept is clear that in case of continuous random variable, there is no discrete value, right? So it's a continuous function. So then what is the difference between PDF and CDF? Because when I say PDF at 3, it means it is including all the probability value till 0.3, right? Of course, probability at 3. Yeah.
So you are having confusion between PDF
and CDF. PDF and CDF, yes.
PDF and CDF, right?
Yes. PMF and CDF are okay. PDF and CDF are a bit,
so the PDF is generally used for the continuous
random variable, yes.
Okay. And CDF can be used for both, right?
So
CDF is simply So CDF, how generally we define the CDF? I'll just explain you. So it's for everyone, like whoever has seen the lectures or not. So there are, like, I guess 5 important points that has been talked in whole 4th week. Okay, if you are able to grasp the 4 or 5 points, I don't think so there will be any issue in solving any of the question of the graded. Okay, so I'll just go through that. So the first important thing is the CDF of a random variable that applies for both the like whether it's a discrete or the continuous. Okay, so why there is a difference that I'll tell you later, but I'll just explain you what is CDF. So CDF is simply the I'll just explain your doubt also after like 2 to 3 minutes. Okay, so the CDF is simply the CDF, the cumulative distribution function, or many a book refers distribution function of a random variable x is represented by fx of x is a function from R to 0, 1. Okay, so that is defined as if somebody has asked you to calculate the CDF of fx of x, that means you have to do the summation of all the probability value till that point, till this x. Okay, right? So this, from the basic mathematical equation, you are able to clear, like it's a very clear that if somebody has asked you to calculate the CDF till this point, x can be anything. Okay, x can be some alpha. Okay, if that is x is equal to alpha and alpha is some constant, so you have to calculate the probability. You have to just do the summation of all the probability value till that alpha point. Okay, so you have to just calculate till alpha. You have to just do the summation of all the probability value. Like for example, if you are having discrete, so like for example the dice one, if you have thrown a dice, the probability of getting 1, 2, 3, 4, 5, 6, everything is having 6, right? All the 6 values, all the 6 outcome has a probability equals to 1 upon 6, right? If somebody has asked you to calculate the f of till 3, so what you will do that? You just have to do the summation of 1, 2, 3. That's it. Okay, this is the case of discrete one.
3 by 6.
Okay, 3 by 6. Okay, till 3 we are doing the summation. Till 3 means what? You are just doing the summation of all the probability value of till the outcome 3. Okay, so till 3, what were the outcome, or you can say the range. 1 was the range, 1 was the value, that 1 was the one outcome, 2 was the one outcome, and 3 was the other outcome, like the 3 outcomes. And if you have to calculate the CDF till 3, what you will do, you just have to do the summation of all the probability values. This is for the discrete. Okay, I'll come to the continuous also. In the continuous also it's same, but in the continuous you have to integrate it. The PDF in this in the continuous thing is not the probability value direct. It's a, what you can say, the density, probability density value. Probability density means the probability upon its, you can say, some unit range or unit volume. Okay. So in that case, in the continuous case, generally we write it PDF, probability density function. Okay. That is simply the density function that you would have read in, like, for example, you would have read in the childhood or in the class 8th or 9th regarding the density function also. So this is a pretty simple. I'll just explain. Okay, I don't have the space here. Okay, so okay, so for this, for the discrete, what generally we define PMF, probability mass function, and CDF. Okay, probability mass function is simply the probability value at each point. Okay, so this is a probability mass and the probability value at each point. Whatever the, like, for example, I told you the outcomes 1, 2, 3, 4, 5, 6, and you have the probability as 1/6 till 6. You have the probability of 1/6, or you can say the head tail. So you have the probability of 1/2 and 1/2. Okay, this is PMF. So CDF is what, if you have to calculate the probability, like for example, you have to calculate the probability that x equals to 3. What you will do? You just have to do the summation of all the probability till 3. This is a cumulative distribution function. Okay, and now I'll go for the continuous. This was for the discrete one, and for the continuous also you just have to do the same thing. So in spite of the summation of all the probability till 3, here you have to do the integration of fx, and fx is what? You will be given the PDF. fx is simply the PDF of the function, and PDF is what? PDF is the probability density function. It's not the exact probability. This is a function, you can say, of the probability. Okay, where you have the probability upon some unit volume or unit distance or whatever you want to say. Okay, this is simply a density function. Why we are doing CDF? CDF is simply the calculation of the probability till that point. And why we are doing the integration here? Because we have to calculate the area. And you already know integration generally calculates the area of any function. Okay, so from here you'd have got some point, like the CDF, we are doing the summation of past things. Summation of, you have to calculate till alpha or till 3. You are doing the summation till 3. So till 3, whatever the range was or whatever the outcome was, we have to calculate the probability of each of the outcome and do the summation till that point. So probability value, like the PMF value, is always be greater than 0, right? Because the probability value will always be greater than 0 for all the points or all the outcomes. Okay, so CDF every time will do. For example, here I have calculated for x equals to 3. Now I have to calculate for x equals to 4. So what will happen? So till 3 plus the probability value at x equals to 4. That means what? Every time the value of CDF is increasing. So the function whatever will get from the CDF, it will be a non-decreasing function. Non-decreasing means it will increase or it will be constant for some time. Are you getting my point? So yes, it's a non-decreasing means whether it will increase, it can't decrease, because every time we are doing the sum of some value. It can be a very small positive number. Okay, 1/10,000. It can be a very small positive number, but at least we are doing some sort of summation, or it can be a constant. That's why we generally write those functions as non-decreasing. That means it can't decrease. It can be constant for some time. Like the PDF function can be like this, It can be constant for a large set of values, and then it will increase. Okay, but it can't decrease. That's why every time CDF will be a non-decreasing function. That means it will start from 0 and it will go till 1. Why it will go to till 1? Because if we have to calculate the CDF for fx x equals to infinity. Infinity means before infinity, all the values for which the probability was existing, we have to do the summation. And if we are doing the summation for all the possible values before the infinity, so it will take all the values of the probability. And we already know from the basic properties of the probability that the summation of all the probability value for the outcome of some sample space will be equals to 1. That's why the CDF at the end, the plot, whatever you're plotting, will go till 1. Okay, so this is for the discrete also, this is for the continuous also. For the discrete, there will be some gap. Like for example, it will go like this. It can go like this. It can go like this till 1. And in the continuous, the graph will be very much continuous. But it will go till 1 only. So in both the cases, in the discrete, whether it's a discrete function or it's a continuous function, it will start from 0 and it will go till 1. Okay. And PMF for the discrete, simply the positive probability value. And for the PDF, for the continuous step, PDF. That means the probability density function. It's a function of probability, you can say. Okay. It's not exact probability, but it's a function of probability only. Okay. So I guess this is clear. So I guess you were having confusion PDF and CDF. Is clear now, right?
CDF part is okay, sir. But while we are saying PDF, right? So say for example, I am calculating PDF at 3 for a continuous random variable, right?
You are calculating CDF for what?
No, CDF is okay, sir. CDF is okay. PDF.
Okay, you are calculating PDF for what?
For x at 3. For x at 3. So that will be 0. At a particular value, it will be 0, right?
Yeah,
so
it will be 0.
Now let us calculate x less than equal to 3. X less than equal to 3. So doesn't it mean that it includes all the probabilities up to 0.3?
Yeah, it's a CDF only.
So here PDF, PDF itself is behaving like a CDF, right?
No, yeah. If you are asking to calculate the probability such that x is less than equals to 3, it's simply you are calculating fx3. It's a CDF, right? So PDF is what? PDF is simply a probability density. Like for example, it's a uniform function from 1 to 5, right? So how will you represent that? The PDF will be what? The PDF will be 1 to 5. The function will be 1/4, right? So this is a PDF value from 1 to 5. The function, the probability density function is what? 1/4.
1/5, no, sir.
No, 1/b minus a.
Okay, yeah, b minus.
If you calculate the area,
yes,
the area should be 1. Okay.
Yeah, sorry.
Right? So this is the PDF function. This is 1/4, right? And if you have to calculate the CDF, what you will do for each and every time, you just, if you integrate it, okay, you'll get some sort of function that will increase from, if it's a 1, it will start with from 0, it will go till 1, right?
So that's CDF. Yeah, that's CDF.
This is CDF and this PDF.
Then what is PDF? What is PDF?
This is PDF. This is PDF. 1/4 was the function value from 1 to 5. Okay, so the PDF for this function is what? 1/4 from x equals to, x belongs to 1 to 5. Both are included. Okay, but if you are asking to calculate the probability,
is this the probability? 0.25 is the probability?
No, 0.25 is not the probability at each point. I'm telling you from the starting, it's not a probability, it's just a function of probability. It's a probability upon some unit area.
So it's just a representation of how likely the value is going to occur?
Yeah, you can say that. It's just a function of probability.
Okay, yeah.
Yeah, it's the, you can say the almost like, what you can say, the this word represent
proportional
function or a proportion to the probability value. It's almost a probability. Why is in sometimes what happens whenever you are having like uniform distribution? Okay, uniform distribution from 0 to half. Okay, so how will you represent the PDF? So in that case, the PDF value can go more than 1 also, right? So from 0 to half. So what will the PDF function? This will be 2 because we have to get the area at 1. Are you getting my point? 1/b minus a, that is 0.5 minus 0. This 2. So this is a PDF function. This is a PDF function from 0 to 0.5, right? So I think so there is some confusion in PDF, right?
Yes.
Okay, I'll just try to.
Because when professor was explaining about PDF, right? So he solved certain problems like this: x is less than equal to 3, or x is in the range of.
Okay, I'll go through that same PDF. Okay, so the CDF is clear for everyone. So CDF, how will you calculate the CDF? CDF is simply, if you have to calculate till x, if you have been asked, so you just have to do the summation of all the probability value of the outcomes till x. Okay,
yes.
This is clear. This equation is clear to everyone. This is a non. Is it clear, or should I explain this one?
It's clear. What I have understood going through the lecture, that end values whether included or not included, it does not make sense for CDF, right?
This for the discrete. This was for the discrete. For the continuous, you can write anything.
Yes.
Okay,
yes.
you can just remove this also for the continuous. That doesn't matter. Okay, but for the discrete, see, you have to calculate the probability of A. Here, what this has been written. So if you are doing f of B is what you are doing the area till B. So B is included.
Yes.
And you are subtracting A also. Till A you are subtracting, means you are subtracting the A also. That's why
Yes.
A is not included.
Hmm.
Fine. So this is for the discrete. Okay. For the continuous, if you are removing this also, that doesn't matter, because at B, the probability value, the PDF value will be 0, right? Not the probability value will be 0, not the PDF. Okay. Have you got the point? So this equation is fine. This is non-decreasing. I already told. So rest people also reply. If you have any issue, you can just tell me. I'll try to explain. Okay. So this equation is also fine. At the minus infinity, the PDF will be 0. Why? Because at minus infinity there is no outcome, so no probability value. So the probability value is 0. So if we'll do the summation from whatever the point till minus infinity, the CDF will be 0, right? So that's why CDF. And at infinity, the PDF value, CDF value will be 1, because we are doing the summation of all the outcome till infinity. So till infinity means what? We are including everything. So the summation value will be 1. Is it fine to everyone?
Yes, sir.
Okay. So these are the some basic examples. If you go through the lectures, you'll be able to understand now. This is the jump thing. Okay. So we are throwing a dice. The probability of getting all the outcome is 1/6, right? So if for example, this is a plot of CDF, right? So how will you plot that? Okay. So from minus infinity to till till 1. Okay, so till 1 there was nothing. The probability was nothing because we don't have any outcome before 1. At 1 we have a probability value of 1/6. So that's why there is a jump of 1/6, right? So 1/6 is the probability. Till 2, like we have the discrete one, means only we have the probability at 1, right? This is just a way to represent that. So there was a jump of 1/6. If you have been asked, if you have been given the CDF function, like for example this one, and if you have been asked to calculate what the probability at 4, so what you will do, you just have to calculate at 4 what was the jump. So at 4, here is the 4, and after 4, what is the value? After 4, this is the value, something greater than 0.6, and before 4, this is the value, below is around 0.5. So just have to do the subtraction of both the things. If you will subtract, you will get this jump value. This is 1/6. So you can calculate that. So every time if you have been asked, this is for the discrete one, if you have been asked to calculate some CDF or calculate the probability at some point, what you will do from the, if you have been asked from the CDF plot, if you have been asked to calculate the probability, what you will do, it's a simple probability, it's a function. Okay, a non-decreasing function. What you will do is just have to, whatever the point has been asked, like for example, this has been asked for what is the probability that x equals to alpha. So what you'll do, you'll check for alpha plus and you'll check for alpha minus. What are the value? There is a jump in alpha plus and alpha minus. If there is no jump, you can directly write the probability is 0 because there is no jump at that point. Okay. So this is clear, I guess. And then,
sir, if it is if we are given to ask like, okay, what is the probability less than 4?
Okay. Less than 4 or less than equals to 4?
Yeah, any example, yeah.
Okay. So less than 4 means what? You have to calculate. If this is the discrete one, what you will do? You'll just have to do the addition of all the things, 1, 2, 3, right? So if you have been asked probability of the x less than equals to 3, man, what you will see? What is the 3? At 3, this is the value. This is the CDF value, and this is the probability. Are you getting my point? Because CDF, whatever the plot we have plotted, we have already doing the summation of each and every point, whatever earlier to that point was. Like at 3, if we are doing, so we have already included the probability value that was occurring for 1, 2, and 3, right? And that is why we are doing the summation for all the jump. We are doing the summation, like we have done the summation of 1/6, then 1/6, then 1/6. So at 3, we came at this point. So this is the probability so that x is less than equals to 3. Are you getting my point?
Yes, sir. Yes, sir. Yes, sir.
Yeah. So you can just write the CDF value, whatever it's been given. Okay. But for the continuous also, it's fine. Like if you have been given for the continuous also, if the plot is known and if at some point you already know that the CDF value, so you can directly write for the CDF for the continuous also, because what is in the CDF, we have just calculated the area and then only we are plotting the function. Okay. Here we are doing the summation of all the probability value and plotting the function. In the continuous, we are calculating the area of that probability density function and plotting the function. Okay. So this is clear. And then we'll move to, okay. So this is a uniform distribution. So wherever you're having doubt, you can just stop me and ask. Okay, these are the 4 basic properties for the CDF that we have already discussed. The non-decreasing function, and at minus infinity, the CDF will be 0, and all things we have already discussed. So I guess for this and then,
Yes, sir. Please explain binomial, sir. Yeah, this one. Yeah.
okay, so for the binomial,
where did that minus 1.65 that value come from?
which one minus?
In the
Formula, sir.
in the right part, you can see that in the denominator it's written that 1 plus exponential.
This one?
Yeah.
This one he just wrote like how to represent this. There's no, like, even I don't know from where he has wrote this. Just a way to show that, okay, if we are taking the n as very large and large, it will represent this function, like the PDF value whatever we will be getting, or this is the CDF value whatever we will be getting. Okay, this will resemble this function. Okay, and
so it was just for representation.
Yeah, this just to differentiate that. If we are yeah.
So the bracket part, sir has explained that x minus 60 is coming from, like, that 100 into 0.6 is mu. So that is 60 is mu. And this this is NPQ, square root 24. But this 1.65451, from where this is coming, this is not clear.
Yeah, and why is it like that?
Bracket part is clear.
Okay, so I guess maybe it's a this is CDF, right? So CDF, okay, 1.6. I don't know from where he's. Okay, this is the variance. Okay, how did you represent the normal distribution 1/2 sigma?
Sigma is outside square root.
X minus mu. This is how generally we represent this x square upon 2 sigma, right? Okay, so if I'm taking sigma I wrote 2 sigma. Okay, I don't know which equation is using. I'm not sure about that. I need to check this. Okay. So what I felt is he just wrote that to just give you a brief idea how to differentiate like the discrete and the continuous thing.
So it was just shown for the approximation that it can be approximated by using a continuous distribution.
Okay. Yeah. So
because if you are taking the normal, then the cumulative distribution function for normal distribution has not been discussed. It is in week 5, I guess.
Okay. Okay. So this is just a way to, he's just showing that how can the binomial CDF with the plot also, he has just shown how will the binomial with n very large will converge to a continuous, right? This is what sir has told, right?
Yeah.
Sir, one small doubt. Shall I ask now, or do you ask me to wait? Sir, that lower bound we can get in Chebyshev that inequality equation. Whatever value we get,
lower bound.
Yes, lower bound.
Lower bound, where is that lower bound?
Markov's inequality.
In Chebyshev, you are asking?
Yes, sir. So 1 minus 1 by k square, that will give the lower bound only, right? Or do we need to
a greater than equals to? Okay, wherever there is a greater than equals to now, the greater than equals to means what? The value will be greater than equals to, like greater than 5 means what? The minimum value would be 5, right? So this is the lower boundary of anything. This is
so the value of, sir, then the value, it means the value of 1 minus 1 by k square is equal to lower bound, right?
This is the lower bound of any function. Like for any function, I'm telling you, it's not for the Chebyshev set. If wherever it's written this greater than equals to alpha, that means all the function, whatever the function it is, fx. So the function will always be greater than equals to alpha. That means the alpha is the minimum value that can happen for this function. Okay.
Okay, okay, sir. Thank you, sir.
Yeah. So so PDF, CDF, and this week I guess again that CDF has, yeah. Again that CDF only. So all the things we have discussed here, how to so how to calculate the jump, how to calculate the probability value. So I'll just go through the questions also, all the questions from the activity and practice. Maybe that will help you to. So in the 4th week, I guess only CDF, PDF has been taught, right? So next week you will get I guess a topic that is a bit difficult to understand. Till 4th week there is nothing much in this. 4th week there is nothing much to discuss, I guess. So the area and all, you already know how to calculate the area. So this is the PDF function. Okay, so the PDF function is simply what? The PDF function is simply the probability density, like it's a simply resemblance of the probability value only. This is the normal distribution. And if you have to calculate the probability till x naught. So earlier what we were doing for the CDF, we were just doing the summation. Here we are just calculating the area till that point. Okay, so this is the simply PDF. Yeah, come again.
This is the graph of PDF or CDF?
This is a graph of PDF.
Okay, so here say for example, if we are taking a value at x naught, right?
Yeah.
What is the probability at less than equal to x naught, right?
Yeah, this is CDF. So if you have to calculate, this till x naught, the probability value till x naught. So this is generally CDF.
But the graph is a PDF, right?
Yeah, this graph is a PDF. So this how we generally calculate the CDF. CDF is simply the integration of PDF.
Yes.
Right? So see that bigger fx, how you will calculate the bigger f? You will do the summation of chota fs, you will get bigger f. Okay, and if you have to get this smaller, you have to
I
do
think I think I have missed up somewhere, so I will have to go through these lectures again, because this part is only troubling, like PDF and CDF for continuous. Discrete is okay, and here that as what I am saying, you are just saying the same, that I am saying the correct thing, that if I have to calculate the probability till x naught, so this is nothing but CDF, but the graph is of PDF. So this point is not clear.
Yeah, so you have to see, if you are having some plot, then only you will calculate the area, right? So if you have the area, this is the density function, you are calculating the area. If you are calculating the area till this point, this is the CDF of fx x naught. X naught means till x naught, you are doing the summation of all the probability value. This is what from the starting we are talking. What is CDF? You have to calculate the CDF.
Like for CDF function, we are saying that it is a never decreasing function, like it keeps increasing, right?
Yeah, so CDF can be anything. PDF can be anything. PDF can be anything.
But here it is taking a decline, so it's a PDF, right?
Yeah. PDF can be anything. PDF is what? Simply representation of the density value of each point, right? So see, PMF was what? PMF, you were representing the probability value of all the outcomes.
At that particular point, yes.
Yeah. So if you will increase the value, if in like for discrete, we were having 10 points. If you increase this value to 1 lakh, so this function will be represented in this form, right? Right, and we can't calculate the probability for each point. That's why we are representing in the form of density function.
So for normal distribution, the bell curve which we generally come across, so
this
that's a
bell
PDF.
Curve only. That's
a PDF. That's a PDF.
Yeah, that's the PDF. Everywhere you'll get the PDF only, everywhere. So whatever you're presenting, you are just calculating data. Okay, if you are calculating data, histogram you are getting, right? This is a sort of PDF only. Generally, if you calculate the data for, like, for example, weight of the person of whole India, what you'll get a bell curve, right? Like, for example, from 50 to 80. Most of the person in India, the weight will be from 50 to 80, right? And lower, like not 50, like for example, 40 to 80, right? And lower than 40, there will be very less people, and above 80, there will be very less people, right? So everywhere you are getting this sort of things only. Histogram, whatever you are representing, that is a simple resemblance of this one. Okay. I hope this is clear. So PDF is clear, right? So you can go through the lectures again.
Can I ask a simple question? Which
Yeah.
PDF does this correspond to? I'm not able to, I mean, not probability density function. I mean, this document. Where can I find this document?
This document is in supplementary form. I'll just show you.
Yeah, I just downloaded, but I'm not able to see.
Okay, you'll just go to the supplementary, and then in the supplementary you have this
top lecture notes is there.
Lecture notes.
Download the things, yeah.
And then go to this week 4 PDF.
Week 4. Okay. Okay, right. Thank you. Week 4 is what I wanted. Thank you.
Okay. So it's clear. The CDF is clear, and rest there is nothing in this week. If you're having doubt, you can ask. Otherwise, I'll go through all the question or activity question and practice assignment. Okay. If you are having any issue, because most of you have not,
So this is related to approximation. Okay, sir. One more part. In one of the session, you told that while studying continuous random variable, we will be studying many types of distribution like Beagle and other also. But I think professor is just covering only 3 parts: uniform, normal, and exponential. So
you'll read so many. You'll just get confused after like 2-3 weeks. There is so many alpha.
I'm just asking, like log normal and all.
No. See, this is the most popular one. The binomial, the normal is the most popular one. But we'll read that gamma, beta, alpha, and many others are there. Distribution.
Said something. We will one day.
You'll read some more, like 5-6 more in the upcoming lectures.
And, this approximation set, which every time you keep telling that approximation, binomial becoming normal, and that geometry becoming normal. So
that will read that. Yeah, that will read in 6th or 7th week.
Okay.
So how will see in whole whatever I'm telling you, whatever the data you collect, whether it's a binomial, even the binomial, after you're having a large set of data, this will convert to a normal. Everything is generally gets converted to a normal. Only the thing is the number of data sets. If you are increasing the n to infinity, it will get converted to a normal distribution. You'll see with the proof also he has shown. Many times after I guess 7th week, every time we'll go through the normal distribution only. Okay. So I guess see this week only PDF, CDS, how to do calculate PDF, how to calculate probability. This one things are there. What is support vector?
Support part, sir. Could you please explain support? I was coming to this only.
So support of X is what? Support of X is for which and all outcomes the probability value was positive. Okay, not 0. So only one thing. Support of X is what are the ranges? What are the ranges, or what are the value of X where the probability was greater than 0? This is what the support is. Okay, so this is simply the range only. Okay, but you have to exclude those points where the probability value was 0. Like for example, if somebody has defined some outcomes from 0 to 1, and for 0 the probability value was 0. Okay, so you just have to exclude the 0. The support of X will be 0 to 1, excluding 1. You have including 1. Okay, I'll just write it maybe to clarify. See, if you have been asked to calculate the support is simply simple thing. Support of X is what? All the values of X where the probability value is greater than 0. Okay, so all the probability
both discrete and continuous, for both.
Everything. This support is simply the range for all the probability value where the probability is greater than 0.
No, but for discrete in range we include 0 also, no?
See, the support of X is what? Support of X for the discrete is what? Like for example, for the dice case, the support of X will be 1, 2, 3, 4, 5, 6. Because for all the other outcomes, the probability value is 0, right?
No,
the support of X is.
Let us take crossing a point 3 times. So number of heads is 0, 1, 2, and 3. So 0 is coming in the range, no?
0. See, all the value of X, all the value of outcomes from the sample space. Okay, where the probability value is positive. Like for example, I'm having X equals to 1, 2, 3, 4, 5, 6, right? And the probability for this one is alpha, this is beta, gamma, delta, and all. Okay, and none of this is 0. And this is the probability value. So the support of X is 1 to 6. And for example, for the probability for 1, the alpha was equal to 0. Then the support of X is 2 to 6. Are you getting my point? So support is nothing but the range only, excluding some points where the probability value was 0. Okay, see here it is in written. Support contained interval in X can fall with positive probability. So all the points where the probability was positive. Support simply just don't get confused with the support of X. Support of X is simply the range only of X. Only the X you have to exclude some points. So most of the time you don't have to do anything. The support of X will be the range of X, where the range of X is what? For the whichever values of X where the probability is defined, right? Are you getting my point? Like for example, there is a question, I'll go through that and maybe that will clarify your doubt. Anything else from this week? Most of you have not seen.
Sir,
I know.
the support is like it is a range, or it is a subset of that real number R, right?
Yeah, sir.
Where X is within that area, the probability
is
positive.
positive. Yeah, that's
outside that area. If you take any range, then it is 0.
Yeah. So the support is simply the range only. You can.
Yes, and in case of discrete, we don't need the support thing because it is only those discrete points where X is defined. So only those points.
Oh, yeah. Correct.
Okay. And since it is the range that I am taking, instead of writing minus infinity to infinity every time, I can just write that range.
Suppose
A to B.
What did you say for discrete we don't take because? For discrete
because those are discrete points like 1, 2, 3, 4. So those are the only supports. You don't need to define within that range between 1.5 or 1.6. You don't need to write.
But where my probability is 0, sometimes we include that point also in discrete.
No, I'm taking the random variables, taking the values like X equals to 1, 2, 3, 4, 5, 6. So those are the supports.
See, here the support for the integration one, support you can write range also here, right? So better if you're writing from minus infinity to infinity, just write it support of X. Support of X is what are the values for which the fx was defined, right? That's it. So
probability is not 0. Let us understand like this. Probability is not 0.
The probability should not be 0 at that point. So all those points where the probability is not 0 will be included in support of X. That's it. Okay, so this is clear, I guess. And if we'll go through this week, whoever has not seen, this week is pretty simple, the simplest week of the stats 2. Okay, you just have to integrate, differentiate, that's it, and it will be over. So I'll just go through some examples, some problem. If you're having any doubt, you can just stop me at that point. This was 4th week. Okay.
Sir, lecture 4.2, question number 6 and 7.
Lecture number?
This one only. 4.2, 6 and 7. Question number 6 and 7.
So the first question is pretty simple. Like I already explained you have to, if B is there and A is not, because B is the higher value, right? So if we are doing the summation till B and excluding A should not be excluded. So B is the answer, right? So this is pretty simple. Similarly, you can, range of X is the values for which the X is defined. Okay. X is equal to 4, you can just calculate what is the X equals to 4. So if this is a CDF, this is CDF. So wherever the capital F is written, this CDF, okay, and a small f is written, that can be PMF or PDF. That if this is a continuous, this is a PMF, and if it's a discrete, this is a if it's a continuous, it's a PDF, and if it's a discrete, it's a PMF. Okay. And so if you have to calculate the probability of X equals to 4, means you have to see the jump, like so 4 plus and 4 minus. So 4 plus, what is the value? 4 plus is 0.88. 4 minus is what? 6.68. So you have to do the subtraction. So what is the jump? 0.2 is the jump. So the probability of X equals to 4 is 0.4. Okay, so similarly, 0.2, sorry. Okay, yeah. So which question? This question you have?
6 and 7, sir. 6 and 7.
Okay, 6th one. So is the 6th one. So 6th is what? This is just X equals to sigma Y plus nu. That's it.
Pardon?
So why X? You have to replace that X Y with X, right? So how will you replace X equals to what? Sigma Y plus U, right? See, X you have to replace.
So you have to just write that f of y is probability y less than equals to small y. Then we convert it to basically X. Like you replace that in front of that, then it will be f of X mu plus y sigma.
Yeah, so just have to the X equals to what? Sigma Y plus mu. that replace x with y. Hello. Okay. So
so in the left hand side, we are taking the discrete values of y, and in the right, we are taking with respect to x, right? So I mean, I got the idea, but
so can I tell it?
Yeah, please.
So you have to write the statement that probability capital Y less than equals to small y. That is f of y, right? Capital F of y.
Yeah.
So when you're writing capital Y, in that capital Y, you can replace it by capital X minus mu by sigma, because that is defined over there.
Yeah.
So it becomes probability capital X less than equals to mu plus small y into sigma. If you do the calculation, if you just keep capital X on the left hand side.
Okay, I'll try to do that.
Then it becomes f of x, that mu plus y sigma.
Yeah, the second one is the answer. F of x and mu plus y sigma, yeah.
So, and the next one is the GP. Whatever the GP you are getting, just do the summation till some k point. I guess you'll get the value. So the summation of GP is simply the formula 1 minus, what is that formula? 1 minus an upon a minus 1, something like that. There is a formula, the summation of GP.
Yes, a into 1 minus r to the power n by 1 minus r.
Oh, yeah, correct. A into 1 minus r upon r minus 1, right? So this you will do, you'll get the value. And this simple jump, okay, range is all the points where there is a jump. So this is the range simply. And
so
for this,
we have to use that formula a into 1 minus r by 1 minus r when r is
yeah,
greater
yeah.
than 1. When r is greater than 1, right?
So that's okay. R is greater than, if r is greater than, if r is less than 1, you can take 1 minus r, and if r is greater than 1, you can take r minus 1. So both are same, right?
The denominator, either way, the minus sign will be.
No. So both the places, numerator also will change. Denominator. So see, if r is like one formula generally is a 1 minus rn, 1 minus r, if r is less than 1, and one formula is a rn minus 1, r minus 1, if r is greater than 1. Okay, so both are same. Okay. Because numerator and denominator both are changing, so nothing will happen, right?
Yeah.
So okay, so these are simple, like the basic properties from CDF. So, and the number of questions is also very less in this, because the concepts are very less, so the number of questions can also be very
from 4.4 onwards, there are significant number of questions.
Okay, I'll just go through that. 4.4. Okay. The first question is simple. Okay. The second question is, which of these following can't be CDF? So there are some basic properties of CDF. The summation should be 1, not the summation. For the CDF, this should be a non-decreasing function. For each and every positive, like for all the values, the function should be positive. Those sort of things will be there. You can pick it out which of the following option is incorrect, or which of the following is can't be CDF. Okay, this is also
for
simple
continuous
one.
random variable. I think that's also important.
Yeah, this is continuous. This is asking for the CDF of the continuous random variable. So you can just check whether the function is always continuous, always non-decreasing. The summation should be all at each and every point. The function should be positive. These are all things, basic property you have to check and pick it out which one is not CDF and which one is CDF. And this is also CDF. You have to calculate x equals to 0. X equals to 0 means what? So you have to do the summation of all the x equals to 0 means the value should be 0 only if this is a continuous one. Okay. And if this is asked minus 3 to 0.5, so what you will do? Just have to do the summation till you have to do the summation from minus 3 to 0.5. Okay. If that is if PDF is been given, here CDF has been given. So from CDF also you can calculate PDF. How will you do that? You can just differentiate, you will get the PDF. Okay. Or there is some other method also. to calculate this question. Like for example, this what how we will calculate so till 0.5 we can calculate the CDF, right? So till 0.5 means what? Till 0.5 see the PDF value and subtract the CDF value. This is what? This simply you can write this in this form. Okay. You can write this fx of 0.5 minus fx of minus 3. So this you can get from the whatever the function has been given. This also you get, just do the subtraction. Okay. Here if you have been asked to, yeah.
Let us solve one more question.
What one?
I said let us solve one, sir, then that will bring more clarity.
Okay. So I'll just go through this. See, at 0.5, what is the value of CDF? This is the value of CDF. So this CDF, capital F means CDF. This CDF at 0.5. Can you place it the value 0.5 at, will get the value of f of 0.5, right? What is the value at minus 3? Minus 3 means what? 0, because at minus 1, less than minus 1, the CDF value was 0. So at minus 3, it was 0. So you'll just get the value, whatever you get the value from here, you'll put the value 0.5 here, whatever the value you'll get from here, it will be the answer. Okay, because at minus 3, the value of the CDF was 0. Means till minus 3, there is no probability, there is no outcome. Okay, so the probability value will be 0 till minus 3, because it has been written also till minus 1, the probability value is 0. So till minus 1, there was nothing in the PDF function or in the, okay, yeah.
There is 1 by 4, 1 by 8.
Okay, got it? Okay. So, and again, if you have to calculate the probability x greater than equals to 0, that means what? You have to do the summation of all the points. Okay. So till, I guess, you can do, there can be other method also. One method can be 1 minus probability of x less than 0. That is the one method. X less than 0 means what? You have to 1 minus. So if you have to do the summation of probability x greater than equals to 0, that you can write in the form of complement, right? So f x less than 0, right? This can be written in 1 minus f of x of 0. F of x of 0 is what? F of x of 0 is been given here. So from minus 0, you can calculate f of 0. What is that? Oh, okay. 0 you can calculate from the jump value. Okay, I'll solve this one. Okay. Or one more thing you can do, because we have been given minus infinity to minus 1 we have 0, till minus 1 to 0 we have, so till 0 we have, okay, so this one, so you can just subtract this value from 1, you will get the value. Are you getting the point? Have you got the point? So if you have to calculate,
please solve it.
Okay. Okay. So if you have to calculate f of, not f of, this is what? Calculate the probability that x greater than equals to 0, right?
No, from minus 3 to 0.5.
What, minus 3 to 0.5?
We have to calculate the probability from between minus 3 to and 0.5.
Why?
That question, sir.
Which question? This question only, right?
Yeah,
Okay,
yeah,
this
four
one you're
number.
asking. Okay.
Yeah, 4 number.
So this you can calculate. See, if you have to calculate the probability such that x is from what?
Minus
Can you
3.
tell me the?
Minus 3
Okay, minus 3.
to and lies between 0.5.
Okay, this is continuous thing. It has been written here.
Yes.
Yeah, this is a continuous. So if this is a continuous, so it doesn't matter what is like whether to take equals to, greater than equals to, or greater than equals to. Okay, doesn't matter in that those cases. Whenever there's a continuous thing, you can replace this with greater than or greater than equals to, doesn't matter. Okay, now, okay, so now we are having, hey, okay, so this, what we can write it? We can write this one as f of 0.5 minus f of -3. This we can write.
Yes, sir. -3 also not, sir. -1 we can write because from -1 onwards it's 0.
Fine. So if you'll plot this one line, so this is till 0.5, this is -3. So the area under this area, or you can say the CDF till -3 is what?
0.
Where is that? Till -3 it's 0. Fine.
Yes. Up to -1 it's 0.
It's 0. Now you have to calculate fx of 0.5 only.
Sir, if I put the value directly, value of x taking it as 0.5, so 1 minus 0.5 is half square is 0.25 by 2 is 0.125. 1 minus 125 is 0.875, but answer is not 0.875.
Wait, what is the answer here? Point?
0.875. Yes.
The answer is correct, right?
Okay.
So this is how you have to solve. Like, okay.
Sir, in between you said something that it's a CDF, so we'll have to differentiate. You said something like that.
Okay, so if you have to calculate the PDF from here, so see this CDF, right? So if you'll differentiate, like the CDF is what? CDF is the non-decreasing function that we plot. At each point, you'll have to differentiate. You'll get the PDF, right? Are you getting? So till -1, the PDF will the constant differentiation of constant will be 0. So the PDF will also be 0 till -1. So from -1 to 0, you just have to differentiate this function. You'll get the PDF from -1 to 0. Okay, and from 0 to 1, you have to differentiate this function. And after 1, again the differentiation of 1 will be 0. So from -1 to 0 and 0 to 1, only the PDF function will be defined. Okay.
Sir, how we'll solve this? Like if it is x lies between -1 and 0, and then x less than 1 also, they both I need to add, right? Half x plus 1 whole square, then plus 1 minus x square.
For what? For what you have to add?
For what you have P of x is equal to 0. For P of x is equal to 0. Question number.
For this one.
Yes,
for
yes,
which,
sir.
Okay. So for this one, you can calculate. If you have to calculate x greater than or equal to 0, there can be one other method. Like for example, you can calculate this also, x less than 0, right? This is what?
Yes, sir.
This is f of x0 and 1 minus f of x0. X0 you can calculate from the thing you have been given. X0, either you can put in this one or you put in this one. You'll get the value and you can put it. Have you got the point?
Yeah. No, sir. Actually, यहाँ पे like जैसे x less than 0 है, and okay.
See.
So this value, like अपनी जो दिखा ना, could you please go there to the sheet? X greater than 3 है.
हाँ. So ये क्या है? 1 minus f of x of 0 है. fx of 0 means CDF of 0. ठीक है?
Yes.
CDF of 0 कैसे निकालेंगे? CDF हमारे पास फंक्शन का फॉर्म लाइक एक्सप्रेशन है. तो अगर 0 पुट करेंगे यहाँ पे, इसमें पुट करो या इसमें पुट करो, ये कंटिन्यूअस फंक्शन है, तो 0 यहाँ पे पुट करो या यहाँ पुट करो, वैल्यू सेम आएगा. ठीक है? तो 0 मैं यहाँ पे पुट किया तो क्या आया? 1/2. तो 1 minus 1/2 कितना हुआ? हाफ. Right? The half should be the answer. Half answer.
Yes.
Any other question? Somebody is asking something. Is this clear? Should I move?
Yes, sir.
और ये plot है. This is the plot that you have to, or you have to do CDF. This is also CDF function. Okay. So this has been continuous from here. So there is a jump on -2. So at -2, the probability is 0.3. Okay, so what else happens? So at -2, you have to calculate the probability. So there's a jump, right? So there is a jump of what? 0.3. So the probability is 0.3, right? Or if you have to calculate from 0 to 2.5, so what you'll do? Just have to calculate the area from 0 to 2.5. So 0 to 2.5. How will you do that? You just have to get all the values. Like this will become a trapezium. This will become a triangle. Calculate the area of triangle and trapezium. You will get the value. Okay. Don't ask me how will you get all the points and all. So try. You have not tried, or maybe you have not seen the lectures till now. So you'll go through that. This is a pretty. I am telling you the most simplest week you are going through. Okay. And again, if you have to calculate the x greater than or equals to 1, just you have to do the summation of all the points greater than 1, or you can do 1 minus. Yeah.
सर इसका परसेंटेज कितना आएगा, लाइक वीक 4 से कितना परसेंटेज क्वेश्चंस है क्विज 1 में? What will be the percentage contribution of questions in quiz 1 from week 4?
For week 4, I've seen the question, but I can't. I've not seen the. Maybe we have more sessions. Like we'll be having session. I'll show you. तो वो सेशन में पूछने पे मैं बता दूंगा, आइडिया लग जाएगा मुझे, है ना. So 5th, you have a revision session on 3rd. You have a session on 2nd also. So you have 4 more sessions. I'll tell you. So 31st I'll be taking. So I'll tell you. Okay. So the percentage of which week is consist of more percentage. Okay.
Okay. Thank you sir. थोड़ा पहले मतलब 31st को बता देंगे so that we can feedback little. अगर 3rd को बताएंगे तो एक ही दिन बचेगा. Really tight.
Okay. मैं 31st को बता दूंगा, है ना. मैं 31st को सेशन लूंगा, तो I'll tell you on that day.
Thank you sir.
And the next week I'm saying the 4th, 5th is the PDF again. The same thing you have to do. You have been given the range. You have to calculate. The range will be what? 0 to 1. So the same thing you have to calculate again. Is it a valid? Just do the integration. If the integration is 1, then this is a valid PDF. Again, you have to do the integrate it from A to B. Okay, and integrate from A to B, you have to get the area as C. So C from out of the 3 equations which is satisfying the conditions. Like this is a PDF, and I've told you for the PDF the summation should be 1, right? So you have to do the integration from A to B and get the area as 1. Today is match cricket also, right? Okay, Rajasthan. So this you can calculate, right? So the valid density, you already know that the PDF is there. PDF has been given. So you have to do the integration from A to B and get the area as 1. So whichever out of the 4 condition is satisfying, it will just take it, right? Again, you have to do the integration from 0 to 1. You have to integrate from 1 to 2. You have to integrate from 2 to 3. You have to integrate and get the value as 1. So you'll get from there, you'll get the value of C. Okay, if you are getting the C now, you can, if you have to calculate the probability from 1 to 2.5, that means you have to calculate the area from 1 to 2.5. You can just do the integration from 1 to 2.5.
So this PDF is for discrete, right?
This is not discrete. This is continuous. These all are continuous, man.
Okay.
Yeah, this all are continuous.
Yes,
Wherever there is a written density function, this is continuous.
Yes, sir.
Sir, the first question is in this, it is a valid CDF first, or I think second.
Okay, so this is this third one.
Third one, yeah, but answer is coming no.
Okay, so what you'll do, you just have to integrate this. So how will you
Yes,
integrate this? So 4 by 5
x to the power 4 by 4. Yeah.
And what is the limit?
Minus 1 to 2.
2. So 2 into 2 into 2 into 2, 16, right? 16
yeah.
upon 5.
15. 16 upon 15.
15
Yes.
or 5. Okay, 15. And then minus of -1, like minus to the power 4 upon 15. So this 1, this
Yes.
is valid one.
Yeah, but answer is given no.
This is a valid density function. The answer is no.
Yes.
Such that the function this. Okay. See, yeah, why this is invalid? Because the probability value can't be negative, right? If you'll put -1 here, so the probability will be minus 4 upon 15. The probability value can't be negative.
Sir, while integrating, sir, it will become 3x square, sir. So it will become 12 by 15x square, sir.
Okay, and one more thing. So from the here itself, like if you'll put the value of -1 here,
No,
the probability
that is range, no? That is not probability value. -1 is range.
Yeah,
This is actually the PDF. So
yeah.
This is a PDF, right? The PDF is what? The resemblance of the probability. The PDF can't be negative value, right? Are you getting a point?
yeah, it's a probability, so it can't be negative.
Yeah, it can't be negative value. Whether it's a area also is coming as 1, the PMF can't be PDF can't be negative, right? So you can't get a PDF whose value is negative, like this area. This can't happen because here it is happening. That's why it can't be. PMF is getting negative, right? If you put -1 here, you'll get -4 upon 15. That can't happen.
Yeah. Yes.
So this is clear. And here also do the summation. This PDF. So wherever it is written a small f, this PDF. PDF means simple plot. The area should be equals to 1 for the PDF, not for the CDF. CDF means in the end the value should be 1 for the CDF, and for the PDF the area should be 1. So again you have to calculate the area for all these points. Do the integration. Equate it to 1, you'll get the value of C. You'll get the value of C now. Now you have to integrate it from 1 to 2.5. You'll get the value of probability, right?
Sir, please scroll it up. So in that question itself, what we were discussing.
Can you repeat?
Scroll it down, sir. The last question we were discussing. Yes, sir. This one, sir. This one, sir. Yes, this one, sir. Like it's a PDF, right? Yeah. So the third option, like 0.3, x is greater than equal to 2 and less than 3, right?
Yeah.
So the interpretation will be that the point which belongs between 2 and 3, 3 not included, the probability of all the values is 0.3, right?
Not the probability. This is the probability density function value is 0.3.
Okay, this is the value of the function, not the value of the probability.
If you have to calculate the probability, okay, see, if the values was probability, like I'm just letting your assumption correct. So for each and every point, the probability should be defined, right? But this is not defined for the continuous, right? For each and every point, the probability is 0. Why it is 0? Because there is no area. So we have to calculate the area to get the probability, right? If you are putting probability of x equals to 3. X equals to 3 means what? You'll get a line in the plot. You can't get the area of that line. That's why the probability is 0. Are you getting? I'll just show you. So this is the PDF function. Like for example, this is a PDF. If you're asking this is x equals to 3, you have to calculate the probability of x equals to 3. That means what? This is a line. X equals, right? This is a line only. So the area of line will be 0 only, right? That's why the probability is 0. But if your assumption, whatever you are thinking, that the PDF is a probability value, then the probability value should be something like this point, this value, according to your assumption. But it's not correct.
At a particular point, it is 0. That is clear, sir. I am saying that from 2 to 3. 2 to 3.
So if you have to calculate 2 to 3, we have to calculate this area.
Correct. So it means it includes probability of all the values which are in this range. That's what I am saying.
Yeah.
Correct?
So from 2 to 3, whatever the PDF value is.
Yeah.
Like for example,
can you come back to that question again? Can you come back to that question?
Yes. So from 2 to 3, this is a
not
PDF.
Included. 3 not included. 2 is included.
Yeah. So from 2 to 3. Okay, this is not included. So this is a PDF.
So it is 0.3, right?
This is not the probability value.
This is not the probability.
If you have to calculate the probability, so you have to calculate like from 2 to 2.5 to calculate the area. Because PDF is what density, you have to calculate the, how generally you calculate the, if you have to calculate the area for this function, you will just get the density and multiply it with the unit length. Okay, you'll get the area, and this is how we calculate the probability. Okay. So where were we? So this clear, right? So similarly, see. So just tell me, I've explained you the support of X. Just tell me which of the 4 options is correct.
सर उसका आंसर थोड़ा बताएंगे प्लीज, जो which one the one which you are just explaining now, 0 to 2 to 2.5, like what will be the answer, like if X lies between 1 to 2.5. We have the PDF 0.3 when it is
this is 0.3 into 0.5, 0.15. यही एरिया है ना, एरिया तो यही होगा, इसका लेंथ इंटू ब्रेथ कितना है 0.5, लेंथ कितना है 0.3, so it will be area. The probability is this value. Okay. So just tell me the support of this one.
0 and 1 not including the first one.
Okay. Why 0 is not included?
Because as per support, we are not supposed to take points where probability is 0.
Fine. Yeah. So this is the I guess answer A is the correct answer, right? A is.
Yes.
So I guess it's clear. Now we have to calculate from 0.5 to 0.8 till same thing you'll do. You'll just have to calculate the area. So here also do the integration from 0 to 1, get the value of K. How will you get that? Do the integration from 0 to 1, equate it to 1, you'll get the value of K. Right? If you'll get the value of K, now if whatever you have been asked, like you have to calculate probability from 0.5 to 0.8. Do the area of 0.5 to 0.8. You'll get the value. Okay. So similarly here you have to ask to calculate the 0.5. 0.5 means the CDF of 0.5 means you have to calculate the probability value x less than equals to 0.5. Okay. So x less than equals to 0.5 means you have to from minus infinity to 0.5 you have to calculate the area. So from minus infinity to 0, the value will be 0. So you have to calculate the area from 0 to 0.5. Is this clear to everyone? This PDF, CDF, PMF, CDF. So this is the last lecture, and then so again, so if you have been asked for the uniform 2 to 6 means what? The PDF value will be what? If this is the uniform of 2 to 6, what will be the PDF value?
So it will remain same, like because it is uniform, and from 2 to 6
it will remain same, but how much? What is the value? So this is the uniform from 2 to 6, and 2 to 6 is included, right? So 2 to 6. So this is a constant from the value would be 1 minus b minus a. B is what? 6. A is what? 2. So b minus a, so 1 upon 4. Now if you have to calculate the, what is calculated? 1 to 5. How will you calculate that? How will you calculate from 1 to 5? So what you have to do? You have to do that area of this. How will you calculate that? So here there was nothing. So you have to calculate the area from 2 to 5. So the length is what? Length is 2 to 5. Length is 3, right?
Yes.
What is the width? 1 upon 4. So the area, the probability value is 0.75. Right?
Yes.
So similarly, you can do for this also. Now you have been asked what the probability x less than equals to a plus. The probability value has been given. You have to calculate the value of a. Again, if you calculate the value of a, now you need to get the value of b also, then only you'll be able to calculate this also. Right? So wherever there is a like only 2-3 distribution has been taught here. Most of you have not went through the lecture. That's why you're not like you're not able to get the point, but if you'll go through that, one is uniform, exponential, and normal. All are pretty simple. Just go through the lectures. If you are having any issue, you can ask me. Like first, submit the graded today, and if you have not seen, just start the watching the lectures from tomorrow and complete it by tomorrow itself. And then you will be having session, I guess, on Monday. Sunday or Monday. So you can just ask all your doubts there. Okay. Otherwise, like today's session was like not that fruitful because most of you have not seen the lectures. Okay. So just complete it by tomorrow and then come for the live session day after tomorrow, I guess, on the 29th. Yeah, on the Sunday you have the session. So it's better. This is an open session also. You can just ask all your doubts. So the complete it by tomorrow. And again, day after tomorrow we'll meet and we can discuss all those doubts, all your doubts of the fourth week. Okay, is that fine?
Yes, sir.
Yeah, so I'll just so I'll also close the session because now we are already done. So okay, then good night, everyone. Let's have the dinner. I'll also go for dinner. I'll first watch the match. I'll just make Rajasthan win today.
So would you be able to write your email ID, please?
So Vishal@online degree. This is my email ID. I'll just
MA, it is written MA, so I just okay.
Okay, I'll just copy it in the chat box itself. You can just copy. Okay, I just copied in the chat box. You can copy from there.
Thank you, sir. Thank you very much. Sir.
Okay.
Good night.
Yeah, good night, everyone. So
Thank you, sir.
Thank you, everyone.
Thank you, sir.
Thank you.